Our first set of problems are going to be mole-to-mole problems. These are using our ratio in order to get from one material to the next material. So if you look at problem number 1 on your paper, I've got the equation written here. The question says how many moles of hydrogen are needed to completely react with 2 moles of nitrogen. So for this question, it is asking us for the number of moles of this material, hydrogen, and it wants to know if I have 2 moles of nitrogen, what amount am I going to have there? So we're going to start with what we're given, which is 2 moles of nitrogen. So 2 of N2, 2 moles of that guy. We're going to put N2 on the bottom. There's no coefficient in front, so that means that 1 mole of N2 will react with 3 moles of H2. So our answer comes out to be 6 moles of H2 are going to be needed. You'll continue on with questions 2, 3, 4, and 5, and then you'll be checking your answers at the end of this video clip. Turn the page, let's take a look at the next set of problems. Our next problem says how many grams of potassium chloride are produced. So that's this material right here. It wants us to find out how many grams of potassium chloride are produced if we start with 25 grams of potassium chlorate decomposing. So here's the material we're starting with. This material right here, we have 25 grams of it. So that's what we're starting with. Now, these problems, in order to get from one material to another material, we have to use a mole-to-mole ratio. But in starting this problem, we don't have our moles of KClO3 right here. We have grams. So the first step in order to be able to do this of getting from one material to another material, our first step is going to be converting this material into moles. So we learned last unit that 1 mole of any material is equal to its molar mass, which we have to look up on the periodic table and find out what its molar mass is. So take a minute, pause the video, and see if you can add up all of the atoms in here to find the molar mass of KClO3. You should have gotten the molar mass of KClO3 to be around 122.5556. If you round it up to 122.6, that's okay as well. So now that we've done that, we can find out how many moles of KClO3 we have. So we take 25 and we divide it by 122.55, and that means that we have 0.20 moles of KClO3. Now we can go ahead and figure out how much KCl we have. And we do that by using our mole-to-mole ratio using our equation. So if we look and see, it's actually a 2 KClO3 to 2 KCl. So it's just a 1-to-1 ratio. So that means that we've got 0.20 moles of KCl that are made. But this problem is asking us for this right here, the KCl, in grams. So now that we know the number of moles, we need the molar mass of this guy so that then we can find out how many grams we have. So take a second, pause the video, and see if you can find out how much does 1 mole of KCl weigh. I calculated the molar mass of KCl as 74.5 grams. So now I can take that 0.2 moles and multiply it by 74.5, and that means that for KCl, my answer in grams is going to be 14.9 grams of KCl is going to be produced. Notice that this problem here takes 3 steps. I first have to get my grams of my starting material to moles using the molar mass of that particular material. Then I use my mole-to-mole ratio to get to the new material that I want to know about. Once I have the number of moles of that new material, I multiply it by the molar mass, and that tells me how many grams of this new material it is that I am going to produce. Go ahead and turn the page. Let's take a look at some of the mixed problems. On the mixed problems, I could start you anywhere and ask you to go anywhere. So let's look at problem number 1. It says what volume of NH3, so we want to know this right here, and we are starting with 25 grams of N2. So that means we're starting with a different material, so we're starting all the way over here with grams of a different material. So your steps for number 1 are going to be that you first have to go from grams to moles of the N2. Then you're going to use your mole to mole ratio. You're going to use your moles of N2 and you're going to use that mole to mole ratio from the balanced equation to find out how many moles of NH3. Then, once you have your moles of NH3, you're going to convert that to volume. Now, we haven't done volume yet, but it's pretty easy. 1 mole of any material that is at a gas state that is like that is going to be made up of 22.4 liters. So it's kind of nice. You don't have to calculate any sort of molar mass. All you have to do is know that 1 mole equals this many liters, 22.4 liters. So it doesn't matter the material. If it says volume or it says it's a gas, these are going to be gases. It's always going to be that 1 mole equals 22.4 liters. If it doesn't say volume or it doesn't say gas, then we always use our molar mass to get over here to grams. So that's just one little tiny change we're going to see. Let's see if we can identify the pathway for the next problem. It says if 5 grams of KClO3 are decomposed. So we're starting right here with grams of KClO3. It wants to know what volume of oxygen gets produced. So we're going to make it all the way over to here to a different material of oxygen. So you're going to have to first take those grams of KCl and you're going to have to convert that number of grams to moles of KClO3. Then you use your mole to mole ratio in order to get from KClO3 to O2. And then all you have to do is take those number of moles of O2 and multiply it by 22.4 liters. And that will tell you how many liters of oxygen. I'd like you to pause the video or stop the video and work on these problems in your teams. And then as you are working on them, I do have the answer key posted as a video on Schoology. And as you're working them, watch the video together and see if you did them correctly. You will be going over this on Monday, and I'll expect you to be able to do these problems on Monday. So if you need to, you'll want to review and go through this packet over the weekend along with the video.